So like I said, we're going to take a lot of different vocab words we've talked about, segments, angles, that kind of thing. We're going to use them to start constructing things here in geometry. So we're going to talk about polygons today. So what is a polygon? We've got a closed plane figure with two properties. Now you might be saying, what's a closed versus an open plane figure? Let's give you a quick sketch. Okay, you guys can guess which one's which, okay? Here's one figure. Now one of them's open and one of them's closed. Okay? Which one do you think's open?
The first one.
Yeah, the first one, the one on the left. It's open. You could put stuff inside of it. This one's closed. You can't put stuff inside of it. Okay. So when we say a closed figure, that's what we're talking about. Two properties of polygons, though. You have to have 3 or more segments. Okay. You can't only have 2 sides, because then your figure would have to be. If you only have 2 sides, then it would have to be open, and we're saying a polygon has to be closed. And each side can only intersect exactly 2 other sides. Okay. And all that means is if I were to take a figure like this, you know, why isn't that a polygon? Well, if I examine this side length right here, how many other sides does it intersect? 3. It hits this side, there's 1. It hits this side, 2, and it hits this side, 3. And we're saying a polygon can only, segments, sides can only hit 2 other sides. Okay, a lot of vocab today. Which ones do you think are polygons? Just a quick test. Raise your hand if you think this is a polygon. No. Why not? Malinsky? Open. Psh. Polygon?
False.
False. Why? Intersects more than 2 sides. Polygon? Why is this not a polygon? Donnelly? Okay. Polygons have to be made of segments. And this is not a segment, it's not a straight line. So no. Polygon? Yes. Yeah, it's closed. Every side only intersects 2 other sides. This side intersects this one and this one. And we could go through that for all the sides. Okay. Made of at least 3 sides. So that one is a polygon. All right, sides. We've been talking about sides. I've used that word. I've thrown it out a couple times. Any segment that makes a polygon. Might have 3 sides, might have 4, 5, 6. We'll talk about all the different sided polygons you could have. The vertex, kind of like the vertex of an angle that we talked about. Of an angle, it's where 2 rays meet. The vertex of a polygon is just any endpoint of a side. Where do the sides meet? How many vertices, that's the fancy word, plural for vertex, how many vertices would a triangle have? Rouse? 3, because you'd have 3 intersection points. How many vertices would an octagon have? Alex? 8. Yeah. Okay, very good. All right, convex. 2 other words here. First one's going to be convex, and the other one's going to be concave. And I'll flush those definitions out a little bit after we go through concave. But convex just means you have a polygon. Oh, I thought I changed this. It should be with, add that, that's an important part. With no parts of sides inside the polygon. Now, concave is kind of the opposite of convex. So if convex means you can have no parts inside the polygon, what do you think concave means? Parts can be inside the polygon. Okay, so our definition for concave is polygon with sides that have points inside the polygon. We don't really need to put polygon twice. But I'll show you a difference between concave and convex. Seeing a picture of it makes it a little more clear. That's something you could just jot in the margin there in your notes here when I show you a picture. Okay, so one of these is convex and one of them Try again. One of these is convex and one of them is concave. So convex, no points inside the polygon. Concave has points inside the polygon. What do you think? One of them is convex, one of them is concave. Malinsky, what do you think?
The triangle is convex,
Okay.
and the other one's concave.
Process of elimination. Here's how I like to think about it. You ever heard of something caving in? Like crashes down? Well, that's what it's doing right here. This part, nothing's caving in. This part right here, it's caving into the figure. That's how I remember it. Concave, it caves in. Okay. Convex are the polygons we're more traditionally used to seeing, but we can have concave ones as well. Okay, jumping back, we've got an n-gon. Any polygon with n sides. It's just kind of a general term we use in algebra, especially when we mix algebra geometry together. An n-gon, hey, it's going to have n sides. Equilateral, what's that root prefix mean? Equa. Equal, same. Okay, just like when you talk about equidistant, same distance. Equilateral. Equilateral, any polygon with all congruent sides. So all sides have to have the same length. And similarly, equiangular, any polygon with all congruent angles. So a lot of just foundational work. Nice thing about some of the later chapters, we don't have as much definitions, but we gotta build a base to start with. Anybody need that up there longer? Okay. We talked about that already. And then the last vocab word you've got there is regular. What is a regular polygon? It's kind of the traditional ones we think of. It's any polygon with all sides and all angles congruent. So they're equiangular and they're equilateral. Equiangular, equilateral. What shape do I have pictured here? You know what that would be called? Rouse?
Pentagon.
What's that?
Pentagon.
Pentagon, because it has 5 sides. The prefix pent means 5. Okay. Pentacle. Anybody know what the pentacle is? A pentacle? I think a pentacle, I know because I watched, what's the movie with Tom Hanks? Oh gosh, a lot of movies with Tom Hanks. No, not Forrest Gump. The Catholic Church is involved. Da Vinci Code. Da Vinci Code. And the pentacle is a religious symbol used in that movie. Well, it's got 5 points. Okay, pent means 5. Now the difference between this pentagon and this pentagon, are all the side lengths equal here? No. Are all the angles equal? No, this is an obtuse angle, this is an acute angle. Okay, but it's still a pentagon. Versus this one, kind of the traditional pentagon we think of, or like the building in Washington is a pentagon like this. All sides are equal. All angles are equal. This would be called a regular pentagon. Just because all sides and angles are equal. All right. So let's run through the list real quick in your notes. 3-sided figure, what's it called?
Triangle.
Triangle. 4-sided.
Square.
A square is a special type of this.
Rectangle.
A rectangle is a special type of this. But in general, any 4-sided figure is called a quadrilateral. Yeah. What are some other quadrilaterals? I heard people say square. I heard people say rectangle. Don's? A rhombus. And a rhombus is a special type of... Farley?
Parallelogram.
Parallelogram. Yeah, these are all 4-sided figures. Kite. Kite's another one. How about a 5-sided figure? We just looked at that. That's a pentagon. Anybody know the root word for 6? TK? Hex. Hexagon. You know 7? You know what? What's that?
Hectagon.
Close. Not a hectagon. You're very close though. In track and field, there's an event for women that has this many events. Okay.
I know.
Do you know what, Farley? Or not Farley, I'm sorry, Roman? Fabry?
It's like a heptagon.
Heptagon. Yeah, the root hep means 7. How about 8? Stop sign? Octagon. How about 9?
Nonagon.
Nonagon. Starting to get in some fun names. The nonagon. Now, 10 events in track and field. There's an event that has 10 events. What's that called, Katie? Decagon, decathlon. So in a polygon's called a decagon. But how about 11?
Septagon.
Septagon?
Yes.
It's a good guess. I don't know what it is. Okay? At about this point is when we start using how we talked about an n-gon has n sides. Well, an 11-sided figure, we just call it an 11-gon. Okay? After decagon, we kind of lose that nice little new names form. We just classify it based by the number of sides. What's that?
Yeah, 12 is a dodecagon.
Dodecagon? You ever seen a dodecahedron? It's a 3-dimensional shape. It's pretty cool. We might get to it later in the year. All right. This is just rehashing things we've talked about. So a polygon is a closed figure with the following properties. 3 or more line segments called sides. Each side intersects exactly 2 other sides, so that no endpoints are collinear. All that's saying is you can have a figure like this. Boom, boom. Okay. It doesn't really count because, I mean, really this side right here encompasses this other point, so you really don't need that point. It's not a big deal. Okay. Each endpoint is called a vertex. So that's just rehashing some of the vocab we've done. Let's see what we've got next. Okay, identifying polygons. Tell whether it's a polygon in the first case, and then tell whether it's convex or concave. Who thinks they've got A? Is that a polygon? Who thinks they've got that one? Roberts?
Yes, it is concave.
Yes, and it's concave. Okay, anybody else? What do you think, yeah?
No.
No, why?
Because the points intersect more than 2. The lines, but the line intersect more than 2.
This line right here, okay?
You said it was. You said it was.
That red line right there intersects 1, 2, 3, 4 sides. So this is not a polygon.
No, he don't do that.
Okay, how about B? Is it a polygon? Weber, what, is it convex or concave?
Convex.
Convex. Yep. It doesn't cave in on itself. How about C? Is that a polygon, Farley?
Yes, it's concave.
Concave. There's a point where it caves in on itself. Very good. Okay. All right, what do we got next here? We're not going to worry about, well, let's just look at number 2. Is that a polygon? No. No, because it's got a curved side. They have to have straight segments. Example 2. Classify the polygon by the number of sides. Tell whether it's equilateral, equiangular, or if it's regular. First of all, how many sides does that polygon have? Lind, I think I heard you say it. 8 sides. Okay. Is it equilateral, and how do you know that?
Yes, because it has a little dash lines for each line, so they're all the same length.
Okay, very good. It's equilateral, they tell us, with the hash marks. If they don't have the hash marks, we can't assume anything, but since they put them in there, we know that all those are equal. Is it equiangular? Yes. Again, we see the angle indications that tell us they're all equal. So if it's equiangular and equilateral, what do we classify it as, Katie? Regular. A regular what? A regular 8-sided figure, we call it a regular octagon. Okay? Okay. Take a second. I want you guys to try to classify what you think this is. Okay? Same idea. Try to classify this figure. So we know it's a polygon. I think people agree that. We can always classify it by the number of sides. So looking at this, how many sides do we have? 4. So automatically, since it has 4 sides, we can say it's a quadrilateral. Now, we have to decide, is it equilateral, is it equiangular, or is it regular? Are all the sides equal? No, they don't tell. These two are, but not all of them. Are all the angles equal? Nope. This has got two arcs. This only has 1. So they're not equiangular. Therefore, it can't be a regular. So the best we can classify it as is a quadrilateral. Now, it's a special type of quadrilateral that we haven't really talked about yet, but I saw some people jot it down. Farley, what type of quadrilateral is this?
Trapezoid.
It's a trapezoid. Okay. But all we're looking for right now is quadrilateral. Okay. All right, last exercise, using a little algebra now. The head of a bolt is shaped like a regular hexagon, 6-sided figure. The expressions shown represent side lengths of the hexagon bolt. Find the length of a side. If you know it's a regular hexagon, tell me about the side lengths.
Equal.
Have to be equal. So how could we use algebra to try to find the side length here? If we know sides are equal, Weber, how could you set this up? What do you think?
4x plus 3 equals 5x minus 1.
Yeah. If it's a regular polygon, the sides have to be equal. Well, then I could set the sides equal to each other. All sides are equal. Now, how do you work it when you've got variables on both sides? Dana? Fence post, yeah. Should we get all the x's on the left or the right?
Right.
Technically, it doesn't matter. We could get them on either side, but I'd suggest putting them on the right because if you were to subtract 5x, you'd have negative x's over here. You'd have to divide by a negative, flip the symbol. You know, if you get all the x's over here, you won't have to worry about it. Okay, so they don't really give us a spot to put our fence post steps, but if we were to subtract 4x, and what would we want to get rid of on this side? The 1. So to get rid of a minus 1, we would add 1. I'm going to do it all in one step. So these cancel, and we're going to get 4 equals x. Oh, that one's so bad. So now to find the side length, just plug in 4. 4 times 4 plus 3, we're looking at 19. Okay. All right, you guys have the tools you need.